I'm Anil Kumar sharing with you a very interesting question from my student who wants to understand how to draw a length which is equal to a rational number. So for that I've taken two different values and we'll discuss different ways of drawing it, okay? So the question here is, draw line segments with the lengths listed below. Describe your result to ensure exact length of the given irrational number, right? So we have taken two numbers. One is square root 3, the other one is square root 5. As you know, these are irrational numbers. We don't know their exact values. So on a calculator, if I do square root 3, for example, and check the value, then the decimal value is not repeating kind of thing, right? So it goes on and on forever. Similarly, square root 5 also will give me, square root 5 will also give me a value in decimal, which is kind of irrational number, which doesn't repeat. And therefore, we cannot write this as a rational number. So they are irrational numbers. Now the thing is, how to draw them, or how to draw an exact value, line segment representing this length, for example. So I'll show you different techniques to do it. The base basically comes from Pythagorean theorem, which you all know. In any right triangle, for example, so if I have a right triangle, for example, like this, then you know that a square plus b square is c square, right? So if these are the sides, a, b, and c, then what we know is that c could be written as square root of a square plus b square, correct? So that's the whole idea. So if I have a scenario where, well, if I want square root 3 here, I could do square root 2 here and 1, and when you square them, you get square root 3. So you could do that, correct? Now, how will you get square root 2? Well, that's another question. We'll see that also, okay? But we could get square root 3 in another way also, which we have got many times using special triangles. What we observe here is that if we have a right triangle whose sides are like 1 is the base and if 2 is the hypotenuse. So if this is length of 2, right, you can always measure and make length of 2 units. And if this is 1 unit, then how much is this? Well, this will be square root of 2 square minus 1 square, right, which is equal to square root of 4 minus 1, which is square root 3, correct? So you could get square root 3 as one of the sides, smaller side of a right triangle, by taking hypotenuse as 2 and base as 1. So that could be an alternate way to get square root 3. So this is without getting into square root 2, right? Okay. Well, making square root 2 is not difficult, you know. Isosceles right triangle with unit length will give you square root 2. Let's look into square root 5. To get square root 5, I'm looking for these squares to be 4 and 1. So that means 2 and 1. So that is easy. So square root 5, I could get if I have unit length as one side and 2 units on the other side, right? So these are 2 units. So if I join and make a right triangle, what do I get? Well, this is 2, right? This is 2, this is 1. And we have here 2 square plus 1 square root, which is square root 5. Perfect, right? So that is how you get square root 5. So you could get them direct also. Well, the standard technique which most will be talking about is a very ancient and very, very good way of representing all these irrational numbers is kind of like this. So if you have 1 unit here and 1 unit like this, in that case, the diagonal, right, so this diagonal will be square root 2, right? So if this is 1 and this is 1, then this diagonal will be square root 2. Perfect. Now, if I make a change here, and well, this is 90 degrees. So if I again have one unit in this direction, which is kind of perpendicular, correct? And then if I join it, then you will see that base is square root 2, this is 1. When you square them, you get this side as square root of 3. So you could do square root 3 in this fashion. And if you continue with this pattern, right, kind of one unit, kind of like, this is not very accurate. I mean, this should have been kind of like this, okay, right angles, I mean. And if I make this one unit long and then connect it, what we get is 3 plus 1, I mean, so 4 square root, I get a length of 2. And after that, if I do another one, means kind of like this, right? And then join, I mean, it doesn't look like that, but anyway, you get my point. So it is 1, this will be square root of 5. So we could just continue with this. It should have been bigger and bigger as we moved along, but my 90-degree angles were not fair enough. So anyway, that was alternate way of doing it, but I'll prefer to straight away draw my triangles for these values. For square root 5, 2 and 1 will give me square root 5, and for square root 3, I will like to draw like this, where hypotenuse is 2. One of the sides is 1, and the other side will be square root 3 for me, correct? But there are many ways to do them. I hope the concept is clear. It is to use Pythagorean theorem and then get the irrational number as either the hypotenuse or one of the sides. So both, be open for both the solutions. That is what I am laying stress on, rather than just looking for hypotenuse to be irrational. Okay, I hope you understand and appreciate it. Feel free to write your comments, and thanks for watching.